Hello students. So students, today I'll make this doubt, and this particular doubt falls into a special category. How I'll discuss you while I discuss the solution of the question. You'll see. आप लोग इस क्वेश्चन में क्या है कि आपके पास ये चार्जेस हैं +8 माइक्रोकूलम -1 माइक्रोकूलम -1 माइक्रोकूलम +8 माइक्रोकूलम are fixed at the points minus of root 27 by 23 meter minus of root 3 by 2 meter plus root 3 by root 2 meter and plus root of 27 by 2 meter. Right? So यहाँ पे इसमें स्प्रिंट है. This root of 27 by this plus root 27 by 2 and this what minus root 27 by 2 respectively on the y-axis. And a particle of mass 6 into 10 to the power is 4 kg and of charge plus 0.1 microcoulomb moves along the negative x direction. Its speed at x equals to plus infinity is v naught. जब पार्टिकल प्लस इंफिनिटी पे है तो उसकी स्पीड v naught है. ठीक है, नेगेटिव x डायरेक्शन में. तो आपको v naught की मिनिमम वैल्यू बता रही है इसके लिए पार्टिकल ओरिजिन को क्रॉस करें. मैं इसका एक रफ फिगर बनाता हूँ जैसा जिससे कि जो है आप देखेंगे. दिस इज y-axis और m मास का चार्ज पार्टिकल जो कि m मास और चार्ज +1 माइक्रोकूलम्स आपने इसको थ्रो कर दिया v naught वेलोसिटी से. और जो चार्जेस हैं दे आर एक चार्ज यहाँ कोऑर्डिनेट प्लस रूट ऑफ 27 by 2 माइनस रूट ऑफ 27 by 2 और एक यहाँ कोऑर्डिनेट है माइनस ऑफ रूट 3 by 2 यहाँ प्लस रूट 3 by 2. इन पोजिशंस पे जो चार्जेस हैं दे आर 8 माइक्रोकूलम्स पॉजिटिव 8 माइक्रोकूलम्स पॉजिटिव and -1 microcoulomb -1 microcoulomb. These are negative charges. So these are the charges. This charge part is thrown along this direction, and you have to find the minimum value of v naught for which it crosses the horizon. Right? For which it crosses the horizon. All right. You'll see students now. आप एक चीज ये देखोगे सपोज आपको क्वेश्चन ऐसा दिया जाए there's plus q charge on this ring plus q1 charge on the ring of radius r and a plus q2 charge of mass m is given a velocity v naught from infinity. What is the minimum value of v naught? V naught minimum equals to what for which this charge plus q will cross the center of the ring. Will cross the center of the ring. Right? इन दोनों क्वेश्चंस में डिफरेंस क्या है? इसमें कि plus q charge plus q1 charge is on the ring. Radius of the ring is r, and his plus q charge is given a velocity v naught from the infinity towards the center. So what is the value of minimum value of v naught for which it will cross out? यहाँ पे there is a difference. Difference is what? Due to this plus q charge, electric field due to the ring will always be along this direction. At this point, near the ring, near the center, or even far away from the center, the electric field will always be along what? Away from it. So that means when this charge particle moves along this direction, electric field will apply force on it towards the positive direction of x-axis. Electric field will apply a force on the plus q charge towards the positive direction of x-axis. So that means when you want to make it cross the horizon, that means anyhow it has to reach up to the horizon. When it reaches up to the horizon and just crosses it, then only it can cross it. Right? Now, in this kind of question, you'll see. आप इसमें क्या है? इसमें कुछ नेगेटिव चार्ज की इलेक्ट्रिक फील्ड होगी. इस पॉइंट पे मैं बात कर रहा हूँ. I'm talking at this point. नेगेटिव चार्ज की फील्ड इसको और नेगेटिव चार्ज की फील्ड होगी इसको और इसको. एक एक कंपोनेंट इसको होगा और एक कंपोनेंट इसको होगा which will cancel. And at the same point, पॉजिटिव चार्ज की फील्ड इसको होगी. एक कंपोनेंट इसको होगा और एक एक कंपोनेंट y, negative y और positive y में होगा which will cancel. So that means at any point, electric field will be due to the negative charge it will be towards the horizon, and due to the positive charges it will be away from the horizon. Is that clear? So this may happen that up to some point from the infinity, electric field is along the positive direction of x-axis, and at some point it becomes zero. When both the fields becomes equal, the net field will become what? Zero. And after that, electric field will be along this direction. So that means what? In this case, you need to give it such a velocity that it goes up to that point where electric field becomes zero. Where the electric field becomes what? Zero. Is that clear? And after that, when it reaches up to that point, because electric field itself becomes toward the horizon and it is a positive charge, this will be dragged towards the horizon. That means what? When the question is that you want to make it cross the horizon, it's not really that you want to make it reach up to the horizon. Rather, you need to find that point where electric field, net electric field is what? C. So exactly up to that point will make it reach. And after that, because electric field will be along this direction only, it's a positive charge, so this will automatically move up to that point. This was the difference. So you see, now for this question, the solution would have been in this form. It's only from the law of conservation of energy. It is what? At this point, the kinetic energy is half of mv naught square. At this point, the kinetic energy is half mv naught square. Right? And because it has to reach up to the horizon, it has just to reach up to the horizon. And beyond that, it will then cross it. So we take that at the horizon, that is at the center of the ring, its kinetic energy becomes zero. Initially, potential is not zero because it's far away from it, far away from the ring. So the electrostatic potential is zero. Kinetic energy is this much, which you are given. And kinetic energy at the horizon will be zero, that is at the center of the ring. And potential energy will be 1 upon 4 pi epsilon naught into q1 by r into q. So through this, you can get the value of what? P naught. So that was a simple question, right? kinetic energy plus potential energy at the infinity will be equal to kinetic energy plus potential energy at the center of the ring. And when it reaches up to the center, it will cross the center of the ring, because on the other side of the ring, the electric field is in the other side toward the negative direction of x-axis. So it will automatically move in that direction. Now see in this question, now look at this. In this question, you need to calculate. Suppose this point is x. This is x. This is what x. This distance is x. And this is y1. This is also y1. And this distance is y2. This distance is y2. So this is also y2, right? So electric field at this point due to the negative charge which is towards the origin, that is what 1 upon 4 pi epsilon naught into. I take that this charge, amount of this charge is q1, negative charge is q1. Direction I have already taken, that is towards the origin, so I need not to write the sign of the charge. q1 divided by what? Electric field along this direction will be, this is x, this is y1, so it will be square root of, it will be x square plus y1 square. And you see this is theta, its cos component will be towards the origin, and cos theta will be equal to what? Cos theta will be equal to x divided by square root of x square plus y1 square. X square plus y1 square. This is electric field due to what? Q1 charge, that is both the negative charges, multiply it by 2. So that becomes due to both the charges. And at this point, electric field due to the Q2 charge, Q2 is the positive charge, say, electric field due to that charge will be 1 upon 4 pi epsilon naught into Q2 divided by what? This will be divided by x square plus y2 square into what? X square plus y2 square. Right? X square plus y2 square. This is y2, this is x. So electric field will be 1 upon 4 pi epsilon q2 divided by x square plus y2 square. And its cos component, cos theta, will be equal to x divided by square root of x square plus y2 square. This is the electric field due to the q2 charge. So as I told you, up to some point when you calculate, you find electric field is along this direction. So you need to give some velocity to overcome the force of that electric field. Then comes a point where the electric field of negative charge, which is towards the negative, which is towards the origin, and electric field of the positive charge, which is positive charge, which is away from the origin, will be equal. So through this equation, you'll find out what? Find out x. You'll solve the what? X. Once you solve x, then see, आपने x solve कर लिया. अब आप law of conservation of energy apply. What? Half mv naught square. Initial kinetic energy plus initial potential is what? 0. Why potential is 0? Because it was at the infinity. Will be equal to initial at the point where the distance is x. What will be the potential energy? Potential energy you need to calculate due to the negative charge as well as due to the positive charge. So I first find out the potential at that point. Potential will be equal to 1 upon 4 pi epsilon naught into what? This will be into 2, because Q1 and Q2, there are 2 Q1 charges and 2 Q2 charges. 2 into minus Q1 divided by square root of x square plus y1 square plus Q2 divided by square root of x square plus y square. And the value of x you have already calculated. You keep this that value of x here. This is the potential. Potential into charge q. The charge which was thrown. This charge plus 0.1 microcoulomb. Potential at that point into charge q will be the potential energy, and the kinetic energy at this point will be zero. Why to be zero? Because you just want to make it reach up to that point. So kinetic energy is zero, right? Through this you can get the value of what V naught. Through this you can get the value of what V naught. You see, one more question can be asked from this. Suppose you are given the velocity V naught, what you calculated in this part. When you give this much of velocity to the charge, what will be its velocity at the origin? What will be its velocity at the origin? So when you know the value of V naught, you will calculate initial kinetic energy is what? Half mv naught square. Initial potential is what? Zero. Find out the potential at the origin due to all the four charges. Find out potential at the origin. So potential at the origin multiplied by Q will be the potential energy plus half mv square will be the kinetic energy. All right, students. So I just gave the example that you need to differentiate. You need to microscopically observe the questions. Both the questions looked to be similar, but there was a difference. In one case, the direction of electric field was continuously in the same direction. So when the charged particle was thrown, it had to overcome the force of electric field to reach up to the origin. And in this case, the electric field was away from the origin up to some point. Then it became zero, then it is towards the origin. So that means now in this case, when they say that for what value of V naught, it will cross the origin. You need not to make it reach directly up to the origin. You need to find that point up to which you need to send it. Beyond that, it will automatically. All right. So, students, these are the microscopic points in the physics when you identify all such things, and how can you reach up to those points? Only by practice. Practice is the only way in which all kind of questions will come to you. Then you will generate the concepts. All right. And my effort will be to bring all such microscopic points up before you. But you also need to practice that. You come across a question, when you get the wrong result, then you come across the right solution also. You find out where is a mistake and what is the correct answer. All right.